In this video, I want to take our understanding of sorting with indexes to the next level. In our first lesson, we discussed how we can use single field indexes to sort on queries. Since then, we've learned about compound indexes. In this video, we'll discuss how we can use compound indexes to sort on our queries. Let's continue using the people data set, and we'll continue using the index from our compound index lesson. The most simple way we can use compound indexes for sorting is to use the index key pattern as our sort predicate. When we run this query and look at the explain output, we can see that we're doing an index scan, which shouldn't be surprising since we're matching the same index keys in the order that they were specified during index creation. This is very similar to how we work with single key indexes. But we don't have to use all of our index keys in our sort predicate to prevent an in-memory sort by doing an index scan. Here's another query. This time I'm only using the first two fields of our index. But when I run it, you'll notice that I'm still doing an index scan. And this is because I'm using an index prefix for our index. If you look at our query, we did job1, employer1, which is a prefix for our key pattern, job1, employer1. Let's try another query and see if we're still able to use the index for sorting. Instead of sorting by job and then employer, this time we're going to sort by employer and then by job. And if we look at our winning plan, you'll see that we did a collection scan followed by an in-memory sort. And unsurprisingly, this is because we didn't use an index prefix. Last time we did job, comma, employer. This time we did employer, comma, job. This means that all of these following sort queries would use an index instead of an in-memory sort because all of their sort predicates are index prefixes. And it doesn't matter what the query predicates are. The server really doesn't like doing in-memory sorts. So in the following example, it's still going to use an index to fetch the documents because we have an index prefix in our sort predicate. So even though we're only returning one document, we still have to look at all 50,000 documents because the index scan was used for sorting, not for filtering. The server was going to have to look at those 50,000 documents either way. It didn't know that there's only going to be one document returned. But an index can be used to both filter and sort documents if the query includes equality conditions on all of the prefix keys that precede the sort keys. Let's look at this example. This was a very fast query because we were able to use indexes for both filtering and for sorting. And this is because these keys are an index prefix. The first keys, job, employer, are an index prefix. But continuing onward, last name would complete another index prefix. I've modified this query slightly so that I will no longer be able to use the index for sorting. Job is still an index prefix, so we'll still be able to filter documents using the index. But since job, comma, last name is not an index prefix, we'll no longer be able to use the index for both filtering and sorting, as we'll see now. So we were able to use the index for filtering. We only had to examine 99 documents for the 99 returned, but we still had to do an in-memory sort. The index was first used for filtering, and then those filtered documents were then sorted in memory. The last topic I want to talk about in this video is about sort direction when sorting on multiple fields. In the single key index sorting lesson, we saw that we were able to walk our index backwards by inverting the key in our sort predicate. You might be wondering, how is this going to work with compound indexes? Well, it's actually surprisingly simple to determine if your sort key pattern will be able to walk the index backwards. If I was to create the following index, we know that the following sort predicate would walk the index forward. In order to walk the index backwards, all we need to do is invert each key. All of the following sort queries would use the index for sorting. The first two would walk the index forward because they're index prefixes. The last two would walk the index backwards because they're the inverse of these prefixes. We can look at an example with our people collection. Here I'm sorting on job descending, employer descending, which job ascending, employer ascending would be an index prefix. So here I'm just inverting the ascending version. And when we look at the explain output, you can see that I use the index, and rather than walking the index forward, we're walking it backwards. But if I were to change one of these keys, we would then have to do a collection scan followed by an in-memory sort. Let's recap what we've learned. We learned how to sort our queries by using index prefixes in our sort predicates. We also learned how to both filter and sort our queries by splitting up our index prefix between our query and sort predicates. Important to remember that our query part has to precede the sort part, and that these have to be equality matches. And finally, we learned how to sort our documents with an index if our sort predicate inverts our index keys or their prefixes.